and welcome back to Instructor Lesson Online Tutorials. In this video, we're going to solve for the derivative of y with respect to x to this expression. Now, the first point is to identify what kind of expression is this. In calculus, we have different parameters under calculus. We have the parametric equation, we have the quotient law, we have the product law, we have the chain rule, which is the function of the function, a function of a function. We have what we call the asymptote, we have the implicit function, and a lot of them. The logarithmic function, the exponential function, as the case may be. So looking at the expression, it looks like an implicit function. Why do I say it looks like an implicit function? Because we have the x and y variables coming together, and at some point for you to be able to separate them, it's going to be done implicitly. So at this point, let's see how we can be able to reduce this expression and have the derivative of y with respect to x to that. Firstly, I will reduce this expression at the left hand side. If we have, by the virtue or the basic understanding of algebraic expansion, when you have x plus y all squared, it literally means that you should duplicate this x plus y into 2. So it will have x plus y into x plus y. And the result of this is to multiply the first term by the first term again by the second term by the first term, and the second term by this. So x multiplied by x will give x squared, plus x multiplied by y will be xy, and y by x will give us xy, and y by y will give us y squared. And then if you sum up this, xy plus xy will give us 2xy plus y squared. This looks strenuous. What if the power increases to 5? Would you be able to duplicate this into 5 and then follow this process? Which is why the idea of a Pascal triangle comes into play to help us reduce this. So if I have x plus y all square using Pascal triangle, I will have to build the Pascal triangle for the first term, and we have for when x to the power of 0, x plus y to the power of 0, x plus y to the power of 1, and when we have it to the power of 2, we have this. We have to do it in such a way that it looks like a triangular array. That's why we call it Pascal triangle. So now I'm having for power of 2, so I'm using this expression. How do I apply it here? 1 by x will give us x all squared, plus 2 by xy will give us 2xy, plus 1 by y will give us y all squared. Look at it. One line, we have the same answer. That is what Pascal can help us do. So we're going to use Pascal triangle to reduce this instead of having to follow the normal algebraic expansion. So that makes things easier for us. So if you don't understand the Pascal triangle, maybe drop a request in the comment section. I will do a video on Pascal triangle and simplify it so that you then understand the concept. So at this point, looking at this expression, we can easily expand this using Pascal triangle. We have 1, 1, 1, 1, 2, 1, 1, 3, 3, 1. How? 1, 1, 1. I'll always bring out 1 and end it with 1. And how do I get this 2? 1 plus 1 gives 2, and then I'll end it with 1. I brought another 1, then 1 plus 2 gives 3, 2 plus 1 gives 3, I'll end it with 1. If I want to get 4 to the power of 4, I will start with 1, 1 plus 3, 4, 3 plus 3, 6, 3 plus 1, 4, and then I'll end it with 1. So this is not the topic we are to do today, but I just have to enlighten you so that you'll be able to know how we get the expansion of this. So the first x is for this first one, y is for this. These three are for both of them. So 1 times x will give us x to the power of 3 plus 3 times xy give us 3xy plus 3 times xy again give us 3xy. 1 times y will give us y to the power of 3. Notice that at this point x power is 3. So the next one, it will reduce. When the value of x, the power of x is reducing, that of y is increasing. So when it reduces to 2 here, here it will be 1. Here 3 is, y is to the power of 3, here will be 2, and here will be 1. So the result will be x cubed plus 3x squared y plus 3xy squared plus y cubed. Here, it will be the same thing with this. The only difference is that it will start up minus and end up minus. So that way for this, I'll have x cubed minus 3x squared y plus 3xy squared minus y cubed. That's just the difference between these two. And if you follow it, you or expand it manually, you will still have the same result. So we're going to substitute these two results into this expression. Let's forget about the right hand side at the moment. We're still going to work on it. So quickly, let's write down these expressions. Let's write them down quickly. So we have the first one. For this expansion of this will give us 3 to the power x to the power of 3 plus 3x squared y plus 3x y squared plus y cubed plus this is for this. We have x cubed minus 3x squared y plus 3xy squared minus y cubed equal to x to the power of 4 plus y to the power of 4. I hope that is well, that is interesting. All right. So at this point, what do we need to do? X cubed plus s cubed can sum up to give us 2s cubed. What is the next thing we need to do? Plus this minus 3x squared y. They look alike, but there is a negative sign, so it means that this can cancel out. All right. Again, we have y cubed minus y cubed. Both of them can also cancel out. All right. What do we have left? This plus this. They are the same term. They look alike. By like terms, we're going to add them up to be 6xy squared plus, okay, we've added this already to give us this. So what is left? Nothing. Equal to x to the power of 4 plus y to the power of 4. All right, at this point, we are going to differentiate each of these terms with respect to, we're going to differentiate each of the terms with respect to x. So the first thing I'm going to do at this point, I'm going to differentiate. Of course, you know the basics of differentiation. If you don't, I will drop a link to that so that in the description of this video, so you'll be able to go back to the basics of differentiation so you know how to differentiate. The differentiation of 2x cubed with respect to x will produce 6x squared. That is differentiation of this using the general formula of differentiation, which is a n x n minus 1. If you use this formula to solve this problem, you have this result. All right. So the next one is this. X and y are attached together, so I can't easily differentiate them, except I will have to do that implicitly. How can I differentiate this implicitly? I will bring out the constant, which is 6, and I will open a parenthesis. I will keep x to be constant so that I can differentiate y squared with respect to x. Plus, this time I will keep y squared constant and differentiate x with respect to x. I hope that makes sense. I kept this one constant and differentiate y squared with respect to x. Plus, this time I have to keep this constant and differentiate this one with respect to x. This is equal to the differentiation of x to the power of 4 will give us 4x cubed plus the differentiation of y to the power of 4. Remember, this is y. So because it is y, this is what we're going to do. the answer will still be 4y to the power of 3, but you add the y over the x because we're actually differentiating with respect to x, not with respect to y. So whenever you're differentiating a term that is not containing x, and that is y, what we need to do is to add the y over the x by that term. All right, sorry. So the next step is this: 6x squared plus, if this 6 multiplies through here, of course, the differentiation of y squared will give you 2y. Differentiation of y will give you 2y. Don't forget, you will add the y over the x to it because you're differentiating y term, not x term, or the term containing x. So the whole of this multiplied by x will give 2xy dy over the x. And if this multiplies by 6, then you have 12xy dy over the x. All right, plus 6 multiplies by, of course, this will cancel out. 6 multiplied by y squared, we have 6y squared. This will be equal to, what do we have at the right hand side? What we have at the right hand side is the same thing. We're still going to write them down, which is 4y to the power of 3 plus 4y cubed dy over the x. So at this point, we need to collect like terms. What do I mean by like terms? The terms that contains dy over the x, are going to group them. The one that does not have dy over the x attached to them should also go to the next part. So if I bring this close to this, I will have 12y, or sorry, I'm having 12xy dy over the x is going to subtract this. If this 4y cubed dy over the x crosses to the left, we have minus 4y cubed dy over the x. All right, all this will be equal to, so what then happens to the ones that does not contain x? The one that does not contain dy over the x. Look at the first one here. We have 4x to the power of 3 minus, if this crosses, we have 6x squared minus 6y squared. All right, I think that is all. So finally, what do we do at this point is to collect this dy over the x is common to both sides, so I will have 12xy minus 4y cubed. I'll group them because dy over the x, they are common. Because they are common, I will just pick one and then subtract this. This will be equal to, what do I have at this point? Everything there. And if I'm having everything, that should be 4x to the power of 3 minus 6x squared minus 6y squared. All right, the instruction is for us to find dy over the x. So I'll divide both sides by the coefficient of dy over the x. So I'll divide both sides by 12xy minus 4y cubed. Divide both sides by 12xy minus 4y cubed. So that this can easily cancel out with this. Therefore, dy over the x. Therefore, dy over the x will be equal to, this is the answer, but I feel we can still divide each of these by 2. So if 4 divides 2, we have 2x cubed minus 6 divided by 2, 3x squared minus 6 divided by 2, 3y cubed, or squared rather, divide 12 divided by 2, 6xy minus 4 divided by 2, 2y to the power of 3. This is the answer of this problem. We have been able to differentiate this expression implicitly. I hope this video helps you to understand the concept of implicit function. If it does, please give me a thumbs up in that video. For this video, just a thumbs up, and then subscribe to my channel, turn on the notification, and make sure you drop a comment if this makes sense to you. Thank you. Peace.